So hopefully you guys might remember some of this from Algebra 1, but just to give you a basic idea why we're doing this. Rationalizing a denominator, you basically have to do that because you're not allowed to have like any type of a root. So like a square root, a cube root, a fourth root, etc., fifth root, whatever. We're not going to deal with that. But we're not allowed to have any kind of a radical in the denominator, which is the bottom of a fraction. Completely fine to have a radical in the top of the fraction, just not allowed to have it in the bottom of the fraction. All right, so the process for rationalizing a denominator is literally we're just going to multiply by 1, which I'm just going to put little quote marks because it will not look like the number 1 when we do it. But we're going to multiply by something that's going to manipulate the bottom to get, depending on the question, either like a perfect square root, cube root, fourth root, etc., whatever type of root you're working for. So you're going to multiply by 1, but we're going to put 1 in a format that it's going to create a perfect square, cube, fourth, whatever type of radical we're working with on the bottom. So I have kind of a mixture here today. Most of these are either square roots or cube roots. There's a couple fourth roots mixed in here. But we're just going to start out, and each one of these is just a little bit different. So my very first question, I just have 6 over the square root of 3. Not allowed to have that square root in the denominator. So what I want to do is try to change the bottom of that so I can get rid of the square root around the 3. Does anybody know what you would multiply by here? 3. So you're on the right track. Radical 3. Okay, so all you're going to do, and whatever you do to the bottom, you have to do the same thing to the top. So really, square root of 3 divided by square root of 3, that's 1. Because, bless you. So that way we're not changing the value of the expression because I'm just multiplying by 1. Okay, what will happen, and if you want to skip this step, that's totally fine if you understand this. On the top, I'm going to do 6 times the square root of 3. I can't simplify that or anything. The bottom, 3 times 3 under a square root would be square root of 9. This is our whole goal. That creates a perfect square in the bottom. So it's going to be 6 roots of 3. The bottom becomes 3. You get rid of the radical around the 9. And you can simplify this. Okay, this doesn't happen on every question. Don't you dare touch the radical. But 6 is divisible by 3, so this actually becomes 2 roots of 3, and you don't even have a fraction anymore when you do that rationalizing. Don't you dare touch that. It's so tempting in this because, like, I look at that and, oh, 3 divided by 3. No, you can't do that. Don't touch the radical on any of these problems. Okay. What would you, now this one's different, so this is square root of 7 over 2. So you can look at it just like that, or if you want to think of it as separated or together, either way is correct. But I can't have a radical 2 in the denominator. Can anybody raise your hand and just tell me, what would you multiply that second question by? Perfect. All right, it's just root 2, root 2. All right, now the top here is different than the last question because the 7 is under a square root, so you want to squish those guys together. This would become square root of 14. And then the bottom, again, skip this step if you understand that, but 2 times 2 gives you square root of 4, which gives me the perfect square on the bottom. The square root of 4 is 2. And then again, these questions are so like this. Don't be tempted to be like, oh, that's 7. Okay, because this is under a square root and this is not. So just, it looks like you can simplify it, but you can't. Just leave it alone. This is a square root of 14, which can't be broken down. And then 2 on the bottom, so I don't have a radical. What would you multiply 2 roots of 3 over square root of 5 by to get rid of the radical there? That's it. You just got to get rid of it in the denominator. All right, so root 5, root 5. Now the top of this, I'm going to leave 2 on the outside. The 3 and the 5 both under square root, so we're just going to squish them together. 3 times 5 is 15. Does not break down under square root. The bottom of that, square root of 25. So top of that's 2 roots of 15. Bottom of that is 5. We're not going to touch the radical. Just see 2/5 doesn't reduce. So this is going to be my answer. Okay, is anybody having a question at the moment? Okay, now this is going to get a little trickier. I highly doubt you guys would have, you may have done this, but I highly doubt it. Rationalizing like a cube root or a fourth root. Okay, so I'm just going to rewrite this real quick as cube root of 7 over cube root of 6. Okay, so if you're working with a cube root, you want to create a perfect cube. Okay, now the easiest way I can tell you to do this is to kind of think about the 6 there like it's a variable almost, and I'm going to write that as 6 to the first power. Okay, what I want to do here is I need to get a perfect cube. If the exponent on that is 1, what I want to multiply by is to try to get an exponent that's divisible by 3. So I would multiply that by 6 squared. Okay, now this is always tricky for people with numbers, but if I do 6 to the first times 6 squared, that'd give me 6 to the third, and then that perfect exponent and root would cancel each other out. Whatever you do to the bottom, you got to do the same thing to the top. 6 squared is just going to give you 36. Okay, so 7 times 6 squared, or 7 times 36, is going to give you, on the top, cube root of 252. That does not break down, so if it does, you can do that, but if not, go ahead and leave it alone, which it doesn't here. Now, I'm going to write this, but again, if you understand this, just skip this. If I take 6, I got 1 6 here, 2 more here, that gives me the cube root of 6 to the third. The third root and the third power there cancel each other out, and so the bottom of that is just going to be 6. And I know it seems like kind of a big number, but 252 is not divisible by any perfect cubes, so you can't break down the top of that. And the bottom just becomes 6 because we're getting rid of the radical. All right, now the one next to this is a fourth root. So I need my exponent to be divisible by 4. So if you think about that as 3 to the first, what would you multiply that by to get a perfect fourth? 3 to the third. Does that make sense? What we're doing here, 3 to the third. If I got 1 3 here, I got 3 more here, so I'd have 4 total. The 4 would cancel out with that fourth root. The top of that, whatever you do to the bottom, sorry, that's a 3 to the third, you just have to do exactly the same thing to the top. Now, 3 to the third power is 27. So on the top, I'm going to do 27 times 4. So this is the fourth root, 108. That does not break down under a fourth root. Again, skip this step if this makes sense to you, but 3 to the first times 3 to the third gives you 3 to the fourth. And then what happens there, the fourth root and the fourth power cancel each other out. So I'm getting rid of my radical, and I just have a 3 on the bottom. So then I've rationalized my lovely denominator there. Is anybody having a question? Okay, now variables work really similarly, so the rest of these have a variable in them. So if I have cube root of w, if it doesn't have an exponent, remember the exponent can always be written as 1. If I have 1w and I want to create a perfect cube, what do I need to multiply by there? 2. We need 2 w's, right? All right, so I'm going to do the cube root of w squared. That'll give me w to the third. Whatever you do to the bottom, you're just doing the exact same thing to the top because we're multiplying by 1. I knew it's a super weird way to write the number 1, but that doesn't change the value of the expression then. We're just kind of manipulating it for our purposes here. That sounded kind of evil. All right, so I get 2w, just keep that out in front, cube root of w squared. The bottom of that, I got 1w here, 2 more here, so I get 3 total. And if I'm doing the cube root, and I have 3 of them, those exponent and root cancel each other out there. So I get 2w, cube root of w squared on the top, and then just a plain w on the bottom. Now, this doesn't always happen, but it does here. If I have only multiplication going on, I don't have any plus signs or minus signs. Do you guys notice I had a w on the top and a w on the bottom, you can actually go ahead and cross those out. That does simplify. So this is similar to that very first question. Actually, I don't have a fraction anymore. I still have a 2 on the top and a cube root of w squared. But we're meeting our goal of getting rid of the radical in the denominator. In this case, we just completely get rid of the fraction. Okay, now, this next question, I'm going to try and save you some time. And so I'm just going to kind of circle this really quickly. Okay, now, this is a cube root, right? And I'm just trying to save you some time simplifying. If you have a number under your cube root that you could write as something to a power, I would really highly encourage you to do that just to save some time simplifying. So, could anybody think of a way to write 4 as something to a power? 2 to the second. Okay, so, and this is all I'm going to do. I'm just going to rewrite this just real quick. 4 is 2 squared. This will just, I promise this will save you some time. Okay, now, if I'm trying to get a perfect cube, I've already got 2 2's here, so I only need 1 more. So if I can multiply by a lower number, that'll just save me time simplifying it. So I only need 1 more 2 to create a perfect cube there. Now for the y, that's not too bad. I have y to the first, so to get a perfect cube, I would need 2 more, because I just have 1 here, so I need 2 more. Whatever you do to the bottom, you're just going to do the same exact thing to the top. 2 to the first power is just 2. So all across the top, everything's under a cube root. So I'm going to end up with a cube root. 5 times 2 is 10. And then y squared, and you can't simplify anything there. The bottom of that, again, skip this step if this makes sense to you. This would give me 2 2's, another 2, so 2 to the third, and then 1 y here, 2 more here, so y to the third. Cube root and third power cancel out. So then the top of that, cube root of 10y squared, and then the bottom should just be a 2 and a y. And again, it's so tempting to feel like, oh, 10 divided by 2 is 5. You can't do that here because the top of that's under a cube root and the bottom of that is not. So it feels tempting, but don't simplify anything there because you can't. One's under a cube root and one is not. All right, and I got 1 more at the bottom here. Now this one's a 4th root. So 4th root of 5, I'm not rewriting 2 as anything to a power. So I'm just going to think of that as 2 to the first and then y squared. Okay, how many more 2's do I need to create a perfect 4th root? 3 more. So just do 4th root, 2 to the third. How many more y's do I need? 2, because you got 2 here. I need my exponent to be divisible by 4, so I just need 2 more. And then whatever you do to the bottom, you're just going to do exactly the same thing to the top. 2 to the third power is going to give you 8. So what I'm going to get on the top, 5 times 2 to the third, or 5 times 8, this is going to be the 4th root of 40. And then there's the y squared. Neither of those break down under a 4th root. Like 40 is not divisible by any perfect force, so just leave it alone. The bottom, you would have 2 here, 3 more here, so you have 2 to the 4th and y to the 4th, and that 4th root and 4th power cancel each other out. Again, if you understand that and you want to bypass that step, that is completely fine with me, but this should be just a 2y on the bottom. And again, don't go, oh, there's a 40 on the top, I can divide that by 2. Do not do that, because that's under a 4th root and the bottom is not. Is anybody having a question? Okay, on the back, we're literally going to do the same thing, but the only difference is all the questions on the back, you can actually simplify first, and I would highly, highly, highly encourage you to do that on any of these questions. So none of the ones on the front was that a possible thing, but if you guys remember, if you have a square root, cube root, 4th root, whatever, if you want to do the top and bottom separate, you can. Or if you want to think about the top and bottom all under the same radical, that's true too. Both of those are interchangeable. So what I would tell you to do before you try to rationalize, because I'm just trying to save you some time, see if anything simplifies, and that will make the problem less work to rationalize. So on that question, the only thing I would tell you could do, just exponent properties, I got 3 more x's on the top of that fraction, right? I'm not taking a square root, I'm just literally simplifying that fraction. So that 2 x's on the bottom are going to cancel 2 on the top. So I have x to the third, and then I still have a 3y on the bottom. I did not take a square root, and I still need to rationalize here, but it's going to be a lot less work to rationalize that than it would be the original problem. So only thing, this one's a square root. So if you think about here, I didn't really write it this way when I did it on the front, but let me do it on this question. So 3 to the first times 3 to the first is, and you guys just know this from Algebra 1, but let me relate it back to what I was doing with the cube roots and the fourth roots. This is really the square root of 3 squared, which is the square root of 9. That's why we're doing that. And y times y would give you y squared. Now on the top, this is a tiny bit annoying, but let me do this. So I'd have 3, right? Now I have an x cubed, which I can break down under a square root a little bit like we were doing in our last couple lessons. So I'm just going to rewrite that real quick as x squared times x to remove any perfect squares. So this is a little bit complicated. The top of this I can pull out, bless you, an x from that x squared. Everything else is left under the radical. And then the bottom, this is a square root, so square root and squared cancels each other out. The bottom would just be 3y. The top would have an x out in front, and then it would be the square root of 3xy. And I know that looks kind of complicated, but that's what it would look like if we rationalized the denominator there. Is anybody having a question? Yeah, go ahead.
So on the top, this x and 3y.
Okay, so I'm taking from the original thing here, the x cubed there, I'm just rewriting x, that would be x, okay, I kind of skipped a step. So like an interim right here, if I just multiplied this together, this would be 3x cubed y. And what I'm doing is I'm breaking down that x cubed, because you could take, do you know what I'm saying? So like, under the square root, I can take out a perfect square if I get an x squared. I would still have an x, because 3 is not divisible by our 2 as our root. But that's what, I just kind of skipped writing that out, but that's what I'm doing. I went right from x cubed to writing that out as x squared times x. Does that make sense? If you can simplify the top, you want to do that. It's not always something that you can do. It just kind of depends on the question. Really good question. Okay, let's do, now this one's a cube root. Okay, again, just simplify first and then take your cube root. All right, so you guys see I have 16 over 2, right? So I'd have an 8 in the top. All right, so my a's, right? I got 8 on the top, 12 on the bottom. So I've got 4 more on the bottom. And my b's, I've got 9 on the top, 4 on the bottom, so I've got 5 more on the top. So I did not take a cube root. I literally just using exponent properties, reduce that fraction. So then, the only thing I have to rationalize is that a to the 4th in the bottom. Okay, now, my whole goal, to get a perfect cube in the bottom, I got to get my exponent to be divisible by my root. What would you multiply a to the 4th by to get a perfect cube? 2. Okay, so we're just going to do cube root. I need 2 more a's, right? I got 4 here, 2 more would give me 6, and then 6 is divisible by that root, which is 3. Now, whatever I do to the bottom, I just have to do exactly the same thing to the top, so that way what I'm doing is not changing the value of my expression. Now, I'm just going to do this kind of in one step like I did on the last question. B to the 5th can be broken down under a cube root, so I'm going to rewrite that when I write this out, but I'm going to have 8, which is actually a perfect cube, so we're going to be able to simplify that too. Now, if you have 2 letters in the same term, which I do here, I'm going to have A and B. When I multiply those together, you should write the alphabetical order. So I'm just going to put the A first. Now, I have B to the 5th. Under a cube root, if I pull out any perfect cubes, let me just rewrite that real quick as B to the 3rd times B squared. Put that back together, that's still B to the 5th. I'm just trying to remove anything I can. Now, the bottom of that is the cube root of A to the 6th, which is a perfect cube. So what I can pull out on the top, actually a couple things. 8 is a perfect cube. So cube root of 8 is 2. This b to the third, I can pull out just b to the first. And then the bottom of that, the whole goal of rationalizing is to create a perfect cube on the bottom. That's going to come out as a squared. So we won't have a radical on the bottom. So my answer here, on the top, you'd have 2b, and then cube root a squared b squared, which doesn't simplify under a cube root, and the bottom would be a squared. Nothing else cancels out there or reduces or anything like that. And again, I know it's tempting, but whatever's under the cube root, like don't cross the a squareds out because the top has a cube root, the bottom does not have a root anymore at all. That's the point of doing the problem. Now, this guy, I got a square root, so make sure you're paying attention. What kind of root are you looking at? So 2/10, I'm just reducing this first if I can. 2/10 will be 1/5, right? So I'm just going to rewrite this real quick. I'd have a 5 on the bottom. If I simplify first, it's just going to save me some time if I'm trying to rationalize this. Now I have 3 x's on the top, 1 on the bottom. So I would have x squared on the top. And I only have y's in the bottom, so I'm just going to go ahead and copy that y to the 4th. But now if I'm looking at that, my denominator is 5y to the 4th, and that's what I want to rationalize. Y to the 4th is a perfect square already, so I don't have to do anything with the variable. The only thing I'm going to have to work with is the 5. So this is 5 to the 1st. So I'm going to multiply that under a square root, just another 5. And that's all I have to use here to get my denominator rationalized. The top of this would be the square root of 5x squared, which I'm going to simplify in 1 second. I'm just trying to show you this. 5 times 5 is 25, or 5 squared. The square root and the squared are going to cancel each other out. Y to the 4th, I didn't have to mess around with that because y to the 4th is already a perfect square. That exponent is divisible by the root. What you can pull out here on the top, I can actually pull out an x. The square root of x squared would just be x. The bottom, I'm going to pull out a 5, and I'm going to pull out a y squared. Now I will have a radical left in the top. It'd be x times square root of 5, and then everybody's over 5y squared. Nothing else cancels out there. If you simplify first, though, it should save you some time at the end rationalizing. Okay, and I got one more real quick. This one's a cube, so I got to have perfect cubes to rationalize this denominator. And just real quickly, oh my goodness, 4 over 6 reduces to 2/3. So 4 over 6, I'm just going to do 2 over 3. And then I'm just going to look at my variables. I got 12 x's in the top, 9 in the bottom. So I would have 3 x's in the top if I simplified that. And the y's are actually really similar here. So y to the 8th in the bottom, y to the 5th in the top. So I've got 3 more y's in the bottom. Now I have not taken a cube root here. I'm just reducing that fraction, just using exponent properties. The only thing you're going to have to rationalize here, because y cubed, that's a perfect cube root, you just got to rationalize the 3. Now, I have 1 3. If I'm trying to do a cube root, I need 3 3's. So I need 2 more. So I'm just going to multiply top and bottom by the cube root of 3 squared. Now, 3 squared is just equal to 9. So across the top, I'm just going to multiply straight across. 2 times 3 squared, or 2 times 9, is going to give you 18. And then I have an x cubed. The bottom, 3 times 3 squared, give you 3 to the 3rd. And then I just left the y alone because that exponent was already divisible there. So the 3rd root and that 3rd power eliminate each other. And then on the top, x cubed, you can actually pull out an x there. That's a perfect cube as well. 18 does not break down under a cube root. So the top would be x times the cube root of 18. The bottom would be a 3y. And then again, don't be like, oh, 18 and 3 go to 6. No, that 18 is under a cube root, the 3 is not. So just leave it alone. So many of these problems, you feel like you can simplify something further, but you can't. Is anybody having a question? Okay, if you guys want to get out your homework